And with that, I'll do a review of energy medicine up to this point. And like I said earlier, I do have a couple twists from Monday, some which may be amusing, but I'm hopefully some may add some insight into simple things like buying supplements, for example. It all relates to energy medicine in a way. Everything's energy at its base, but I don't want it just to be a discourse on energy, this boring lecture on chemistry and physics tied to biology. There has to be some practical aspects, and I'll try to cover that. And Andrew, I have a couple things in there for you too, because I know you're piqued about science. But healing is voltage, and I really recommend, if you haven't got the book, get it. It's a little thick, but I'm going to reread it in the context of what I'm learning about energy medicine now, because Dr. Tennant is really a guru on this. And I've showed this before. When I did read it, I took a few notes. I read it pretty thoroughly, and most of it is about medicine, physiology, and biology, and then the energy medicine part is really just a small part of the book. Because if you don't have good physiology, then you're fighting against it when you apply energy. Sunlight. You go out in the sun one day a year, and it improves your mood or improves any number of things. No, it's there to be gone under every day. Exercise, my Labor Day thing. My recommendation on Labor Day is go out and labor all day. That's what the mid-Victorians did. I'm writing about that in my book right now. The mid-Victorian British lived as long as British do today, even longer. And they had 1/10 of degenerative diseases. We have this presumption that they only lived to 40. Okay, if you look at 0 to 6 mortality, which was very high, and factor that in from 0, then yeah, they lived till 40. But if you start at age 6, they actually lived, and compared to Brits today, they lived just as long or longer. So healing is voltage. And when I first read that, I had to remind myself, because I've been zapped by electricity so many times. I'm kind of like, I don't want voltage. But what is voltage? It's proportional to the flow of electrons. So healing is a flow of electrons, or just electrons. We have to have electrons. Okay, so we think about healing, we have cytokines, or we have repair molecules, fibrin, things like that come and heal. We get a little information, and we heal. But really, at the end of the day, the true healing is putting electrons into the system. Damage is an oxidative process in a lot of cases. Oxidative process means a loss of electrons. Therefore, reversing that process is giving electrons. So therefore, electrons heal. Our energy is voltage, the electron. So the other part of this is, okay, so electrons are there to heal, but they're also there to drive energy. So our energy is voltage, the electron transport chain. That's our mitochondria. Mitochondria is a big topic these days, and I think IFM and any number of folks are focusing on mitochondria. I'll be talking a lot about mitochondria next opportunity I have to talk about energy medicine. Might get into it a little bit today, but we're going to try to stay on schedule. Anything that steals electrons impedes healing. Anything that steals electrons reduces energy. Okay, so the two simple things is infection will be doing that. Anything that's oxidizing, a burn, fire, a burn is like fire. That's oxidizing, so that's going to impede healing. Infections that are intracellular that Dr. Carter and I focus on, they're hungry too. They need energy. Electrons are energy, so they take your electrons. It's that simple. So a lot of people have chronic fatigue, and it's been unresolved by any number of practitioners. They're not looking for intracellular infection in a lot of cases. And the first place to look, of course, is the almighty mouth, because that's where most of them come from. Immunity is voltage in reverse. I might have, I won't say I'm wrong there. I'll just say, So if voltage is giving electrons, voltage in reverse is taking electrons away. And that's the way our innate immunity works to get rid of pathogens. So we have this balance in our system between giving electrons to keep us healthy, keep our tissue in shape, keep immunity, and keep energy. And then we have this other process going on at the exact same time, immunity, to keep pathogens at bay. And so it's an interesting dance indeed. Okay, so neutrophils, of the white blood cell count, neutrophil is one type of 5 white blood cells, and steal electrons from invaders. Okay, so steal electrons, and usually when you steal an electron from something living or quasi-living, you're destroying something critical to their existence, like a membrane, and so they die. Antibodies produce reactive oxygen species and steal electrons from invaders or pathogens. And this was published in 2002, thereabouts, by the president of Scripps, that said we shockingly or startlingly found that antibodies that create this little active piece that grabs the antigen or the pathogen, whatever, like this, doesn't just hold it and wait for a neutrophil to come along or another immune molecule. It actually can produce its own antibodies, reactive oxygen species, which are electron stealers, and kill. I said that for a very specific reason, kill, but it's an inside joke. That the electron potentially destroying that pathogen. Okay, so immunity destroys electron stealers that impede healing and reduce energy. So how do we balance that out? And it turns out that some of the things that we have that are like the antibody recognizes a foreign, okay, or better yet, recognizes good things and anything else is a foreigner and it goes after it. That's why we have attack of the thyroid in the context of molecular mimicry. If you have leaky gut, things that cross the gut-intestinal barrier aren't necessarily pathogens, but they're not on the Rolodex of the good guys. So the immune system creates antibodies to grab them. And that Hashimoto's could be described as that. That's not the only cause of Hashimoto's. Periodontal pathogens are well published to cause that same thing. So there's, in my opinion, there's not really autoimmune disease if we dig down deep enough to find out why our antibodies just don't come out of the blue, ever. How can they? We wouldn't survive. Okay, so that's that one, and we're on the wrong place. Let's click this guy here. So we hear the terms antioxidant and anti-inflammatory. And really, since at the end of the day, there's only donating and taking electrons, they're pretty much the same term, different contexts. So an antioxidant provides electrons. Okay, so if something is oxidized, then the antioxidant come in and can antioxidize it. Don't like the term in chemistry, we call it reducing. So we have oxidation and reduction. Okay, anti-inflammatory, the reason why we call them anti-inflammatory is when we do testing, we see markers of inflammation go down. So for example, C-reactive protein, maybe uric acid, fibrinogen, homocysteine, maybe, lymphocyte sedimentation rate, things like that. But at the end of the day, that's happening because there are electrons being delivered. Electrons heal. When you are inflamed, you're just the opposite of healing, and so the electrons help you heal. So markers of inflammation go down, but the root of this process is the delivery of electrons. Now, cod liver, this is an important example, not just because I'm a cod liver oil fanatic. I haven't taken mine yet tonight, but I have a little kombucha here, so I'm ready to wash it down vigorously. But I will gulp a lot of cod liver oil tonight. But cod liver oil is an anti-inflammatory, but a key pathway is the oxidation of fish oils. Thus, it provides electrons. Let me explain. So we worry about rancid fish oils, but there are plenty of antioxidants floating around. So you take in a rancid fish oil, or in your gut, which is strongly acidic, you may oxidize some, but antioxidants will push it back to the unoxidized version. Okay, and then I store my cod liver oil, like I said, on Monday at room temperature. Am I worried about going rancid? What makes it rancid? What's going to oxidize it? Oxygen. Okay, I seal the cap, and there's just a little headspace of air, 20%, 21% oxygen. But you know, when a liquid expands goes to a gas, it expands by 1,000-fold. So the amount of oxygen actually in that headspace compared to all the fish oil in there is spitting in the ocean. So maybe like 0.01% might get oxidized. It's relatively irrelevant. And then in the 1840s, in the tuberculosis pandemic, I can guarantee you the cod liver oil they were giving that reduced mortality by 50% was not stored in a refrigerator, wasn't invented, and was probably pretty rancid. But see, our body has all kinds of tools. It's called taking in fuel as energy that can do all kinds of work, including reducing oxidized fish oils. I think the important point is when you take in a fish oil and it oxidizes, guess what's not oxidizing? In its stead, your tissue. That's why fish oil is an anti-inflammatory. Okay? But really it's an antioxidant because it's giving up its electron, but you don't have to. Okay? But this brings a key point, and I forgot one thing based on my ride, a little set of stairs. But see, everything has, it's not like it's either zero, it's not like computer, zeros and ones. There are different oxidation levels all through our body, all the different molecules, assemblies, everything. And every substance has a different oxidative or reductive antioxidant potential. So hydrogen, you know, that balance has a certain potential. People take hydrogen water because it's anti-inflammatory. Well, the potential anti-inflammatory action of hydrogen might be a little different than that of fish oil. So it might actually affect a different pathway or a different set of, help reduce a different set of oxidized substances than fish oil will. But that's why I say get your antioxidants from vegetables, because you are going to get the proverbial potpourri of antioxidant substances, and they don't all have the same action because they both have the ability, they all have the ability to donate electrons, but at different levels. If you remember your chemistry lessons, energy is quantized. It's not, I always talk about, and Dr. Carter and I have the health disease continuum. When it comes to physics, particularly on an atomic level, there are steps. Okay, so fish oil, in terms of its power, is on a different step than hydrogen is on a different step than some of the phytonutrients that are antioxidant in vegetables. That's why it's never going to be like, hydrogen is my solution for antioxidation. Heck no. And hopefully I'll explain that to you in the coming slides. So last time I said advanced topics, not for this, but this time I'm not for this talk, but this time I'm saying, some of these advanced topics we're going to cover tonight. Okay, so the first thing is, in order for something to work, there has to be the right stoichiometry. And I'll move on, because everybody knows what stoichiometry is, right? Okay, maybe you don't. So like magnesium chloride, I mentioned that because I'm going to discuss it again. Magnesium is +2 and chloride is -1. So you have to have 2 chlorides for magnesium. If you know it, you're not going to make magnesium chloride. But it's a little more complicated than that in physiology, because, you know, in physiology we have these very, very complex molecules. But stoichiometry plays a role. And we could look at stoichiometry in the context of physiology as being, do we have sufficient minerals, phytonutrients, calories? The answer to that one's always yes. But you know what I'm saying. So when I see the erythrocyte sedimentation rate up, which a lot of people know I talk about, there's either an absorption deficiency of minerals or just a general deficiency in intake. Stereochemistry, that's why we have enzymes. They have these extraordinarily complex structures that are wrapped around and three-dimensional, and at the center usually is some type of metal ion that affects transfer of electrons or the accepting of electrons. Transfer can go either way. And these little signs for copper here, the little arrows indicate that this is not one way only, single directional, it's bidirectional. So you can give an electron or you can take an electron away. And it just depends on, does the system have enough energy to do that? But the point is, everything is reversible. That's why I mentioned the fish oil. Oh, it's oxidized. Guess what? That's reversible. That is a reversible process if we have the right physiology and the right nutrients to affect that reaction. But stereochemistry is very important from a context of physiological reactions like repair, like energy in our body, because these very important enzymatic structures, not only do they have the redox potential, but they have the conformation to bring the stoichiometry, that is the two molecules together, like copper and whatever it is, or magnesium and chloride. That's a overly simplified case. We're talking about more complex things like building DNA or large protein structures, to get these things into basically a jig to get them to come together. Otherwise, they might be floating up in space and they never unite. You know, it's challenging to get things to come together. And so we want to have the right sort of template or jig to get that to happen. And that's stereochemistry. And that's why, you know, Dr. Neer talked about the sulfur and how the sulfur amino acids cause this cross-linking. And it's just amazing how our bodies are designed. So like you have this DNA string with all kinds of amino acids. And then you have a sulfur amino acid here and a sulfur amino acid over here, and they fold over to link up. Why the heck they do that? So that that molecule is shaped perfectly. That protein or enzyme protein structure is shaped perfectly for a very specific reaction. I mean, is that amazing or what? I don't know. I mean, the only two things I've seen in life that are just magnificent, because my mentor was an ophthalmologist. He had a series of enlarged photographs on his waiting room wall of various insects' eyes. I mean, just the beauty of these structures were amazing. And then the three-dimensional images of enzymes and other proteins, just phenomenal. You could never build this. One of my so-called mentors, E.J. Corey of Harvard, he chemist and professor emeritus now, but he synthesized some of the most amazing natural products ever synthesized. And what he did, so I always use him as a reference. I say I do retrosynthesis, start from this and you work back to the very, very beginning. What Corey did is he took a natural product and looked at it and then tried to figure out what was the next step from the finished product, and kept working his way back. And then he made all kinds of natural products from that synthetically. And then, of course, maybe developed drugs from that. But, that a lot of drugs are derived from natural products. But he learned a heck of a lot of chemistry from that process. So electromotive force is kind of the flow of electrons. And the electrochemical potential, a really important one. I already mentioned the steps. Fish oil is at a different step than hydrogen is at a different step than some of these natural antioxidant substances. And so that's the electrochemical potential. Literally, it's like bringing water up higher and higher and higher, and then you're going to pour it on a water wheel. The higher it goes, the more you're going to get out of it. If you only bring it up an inch and pour it, there's not a lot of potential energy in that system, and it'll just turn the water wheel a little bit. But if you bring it way up high, gravitational force and whatever will cause that same water to have a lot more force. So here's just an example. Copper's not a really good one. I have others now, but copper can either get reduced from a copper plus, so that means it's been oxidized to copper, and there's a voltage force. So the voltage is really the strength or force, And then here's another one, slightly different force, and so on and so forth. So every one, even copper. Reason why I use this example is you think copper, okay, one voltage force. No, it has many, depending on the so-called oxidation state of the copper. Copper 1, copper 2. And is copper 2 going straight to copper, or is it going to copper 1 first, and then so on and so forth? So you get the idea of the complexity. And our PEMF guy talked about permutation. So there's just so many permutations. That's why we can't think reductionist, like just fish oil is going to solve cardiovascular disease. No, it's much more complex than that. There's so much going on. So here's a good one. This is my new one, okay? And I'm using iodine. And I couldn't find one that just had I2 to iodine. But I'm going to give you an example of how we're treating infection, right? So we can use antibiotics, we can use energy. What's the electrochemical potential of the vulnerable place on the pathogen? Does anybody know that? The answer is, I doubt it. Okay. So I picked iodine, which is an antiseptic. And so you have a little boo-boo and it starts getting a little infected, and you put some iodine on it, and voila, pathogen be gone. Okay? So iodine, I2 to iodide. So iodine is a purple-brown solid, or if you put it, it dissolves easily, you'll get a purple-brown liquid. I2 is two iodines together, and that's the most stable form for it. Iodine alone as a single atom doesn't exist. So it bonds. There's the rule of 8, or the octet rule. It wants to have 8 electrons around any given atom. And iodine, because of where it is in the periodic table, doesn't have it. Only 7. So what it says is, hey, there's another iodine over there. Hey, what if we share one each? And if we share it, then we go from 7 to 8. Okay? And the reason why iodide, the I minus, is more stable is because even if you have twins, they don't always like to share. So one says, heck with you, I'm going to take one of yours rather than share it, and it becomes I minus with 8, so it's perfectly stable. So in that respect, the iodide, potassium iodide, for example, clear, dissolve it in water, is more stable than iodine, but not so much so that they just spontaneously go that way. Then the iodide is very happy, not sharing, has its fill of 8, and it's really happy. But what I say here is what if the oxidation potential of, like, something I have, Toxoplasma gondii, is way out here? Okay, it is way out here. And iodine only has 0.3 force. I won't use voltage or whatever. I'll just say a force of 0.53 in terms of pulling electrons. That's really its pulling power. Okay, what if toxo is like 0.7? Will iodine destroy Toxoplasma gondii? And the answer is no. It will not. So that's why, sometimes things don't work. And we say, it doesn't work. It's no good. It's the underlying principle of how it could work is still valid, but it just doesn't have enough oomph. That's all there is to it. So that's just an example, and I think I have a slide here to show it. Like, I tried to find a good image, but it's like, so let's just say Toxoplasma gondii is the rim, and this basketball player is the potential of the iodine to oxidize, but he didn't quite get up to the rim, so he can't dunk the ball. So did he score any points? He scored 0. Okay, that's kind of what I'm trying to convey there. And then, iodine, there are stronger oxidizing agents. Ozone, your white blood cells, ROS, reactive oxygen species, from your antibodies, from your neutrophils, increasing oxidation, oxygen pressure with hyperbaric oxygen. There's a number of different things. But now, reasoning this, let's just say you do ozone therapy, extracorporeal ozone against something. A lot of people feel benefit. So they have some pathogens that are pretty easy to oxidize. But they may still have some pathogens, more virulent or more sneaky, stealth type, that are harder to oxidize. So guess what? The ozone will work. What is the push of the reactive oxygen species of ozone? It's not infinite. Okay? So it may have limitations. That point, hopefully that point is very clear, because we always like to explain successes. But I always tell some of my colleagues, they do energy medicine, they do photobiomodulation, I always tell them this: when it works, great. When it doesn't work, can you explain why? And like Marvin, for example, Michael, the photobiomodulation. When it doesn't work, why doesn't it work? And that's why I tell them to run our labs, so you can see what's going on. But basically, really, in reality, most people don't understand this. So what I get for an answer when I say, why doesn't it work? And I get sort of like this, it's like they have no idea. But this is basic science, okay? So you guys all know basic science now. Isn't that amazing? Did you think you could do it? Hopefully you did. Can you dunk a basketball? Well, then you're not very good at killing Toxoplasma gondii. So I am going to pick on the magnesium queen, to be nameless. And I was talking to Dr. Michelle the other night, and we were just discussing Remag, and it caused me to contemplate what Remag was, because she's saying it's molecular magnesium. And she might have said ionic molecular magnesium, and if I had picked up on that, I wouldn't have been so piqued. But I heard molecular magnesium, and that is impossible. Okay, but she's not wrong. I'm just gonna give you a little sort of overview, because it's going to help us understand sort of stereochemistry, how things can come together and unite. And some things may come together and unite more effectively than others. Sometimes that's good. Sometimes that's not so good. It varies, but it's all tactical, and I'll hopefully explain that at some point. And if not, well, I'll try. So if we take magnesium in the oxidized state, so in other words, in solution, something you can absorb, and try to convert it to magnesium metal, that's impossible, because it requires a huge amount of voltage. So I had this little dream while I'm riding my bike. I'm saying, I know Dr. Dean knows this, but when she says molecular magnesium, I would just say to her, what if I come to Hawaii with a pound of pure magnesium metal and threw it in your toilet? It would blow the whole place up, So when magnesium goes in solution, it's magnesium +2. That's the only way it can be. Magnesium is fireworks, the thing that creates, the bright white color, and I'm sure they put other things in to give different colors, but that flare up is magnesium going to magnesium 2+. So obviously going in this direction is the preferred, because it's very energetic. And it actually goes, in the case of a firework, it goes to magnesium oxide, because there's oxygen up there. But it's still magnesium 2+. It's no longer molecular magnesium. But this could be considered molecular ionic. But every ion, you dissolved sodium chloride in water, now it's sodium ions. That's molecular, picomolecular, if you will, using her term, sodium ions. Anything that dissolves is molecular by definition. So it's a little bit of a marketing play. So, but it's interesting here that magnesium chloride this is the approximate size of the magnesium atom and then the chloride atoms when they form magnesium chloride. And then when it gets into solution, they dissociate. So they're connected to each other because the whole system has to be electrically neutral, but this has a 2+ and these both have a minus. So they kind of hang out together. And then because the size of these things, when you look at the two and add their size together and the magnesium, they're similar. So it forms this, just like water does, this structured system in water that looks a lot like this. Okay? And this form, just because of the way it's linked together and because of the spacing, and so the sharing of electrons or the attraction between the two bodies is, it's uniform. And the size is, the charge is distributed all over. So when they're both the same size, they have much more attractive force than if they were odd sizes where, let's just say, it was a bigger molecule next to the magnesium, it would be more diffuse, and that level of attraction wouldn't be as strong. So I have this little picture over here, and this is magnesium glycinate. Okay, so you see roughly the same size proportion. The glycinate is much bigger than the magnesium. So what you have is, even though they attract, and you take magnesium glycinate and it dissociates in water to the magnesium ion and the glycinate. So this would be the cation, or positively charged, and this would be anion, negatively charged. And they're happy together. But magnesium is much happier with something its own size. Okay? And so this structure it forms is going to be much more stable than the magnesium glycinate. So I would argue that if you take magnesium glycinate in a stomach full of hydrochloric acid, tons of chloride, that really the magnesium is going to wind up in this form here as the chloride. Because there's an overwhelming amount of chloride ions in your gut compared to a little bit of glycinate that would in with your food. Not to say that the glycinate may not have a small role, and I'm going to explain that too, I hope. Like magnesium threonate. There's really good evidence that magnesium threonate has more access to the brain. But I really believe most of the magnesium in your circulation is magnesium chloride. But the threonate being in there is still in circulation. It can probably fight for a little of those magnesiums, and then it has more probably hydrophobicity, or more lipophilicity. Philicity means liking. And so it can go across the blood-brain barrier maybe more easily. I've read a bunch about this, and no one's really explaining at this level. It's a lot of hand-waving. But they do show data that something like magnesium threonate seems to have a better response for calming the brain than, say, the magnesium chloride or the magnesium glycinate. So I'm going to try to explain that to the best of my ability in a moment. So I have a little quote here from Samuel Clements. It's easier to fool people than to convince them they've been fooled. But when you look at Remag, 8 ounces, so pico-ionic liquid magnesium, and a lot of people assumed that it's like molecular magnesium. It's not. It's ionic molecular magnesium, which means it's simply magnesium that's been dissolved in water and it's floating around as just a magnesium 2, and then it has some counter-ion, chloride, whatever else it has. And it turns out that in Paula Dean's stuff, it's magnesium chloride, son of a gun. And I actually think that's brilliant because it's hard to find magnesium chloride. On full strip, you can't buy it. There's no magnesium chloride. It's all the other counter-ions. But as soon as you take those other ones in, it's magnesium chloride because chloride is overwhelmingly populated. And you got it's the 4th most abundant mineral. Okay? So I'm going to give you, I gave you the cheapest infrared light system, quasi-sauna on the planet, $100 with those halogen lights. Now I'm going to give you the cheapest way to take magnesium imaginable, and you're going to ultimately get the same magnesium you get with all of these things. Having a little threonate, having a little glycinate may have some benefit here and there, but it's predominantly magnesium chloride. So here, guys, I found magnesium chloride. $6.65 for 100 caps. Way cheaper than Remag. And the reason why I want this, because I used to have it, is the Remag tastes disgusting and it upset my stomach. And it's like, I have free samples from Paula, and it's like, oh, Carolyn, I said Paula, Carolyn Dean, right?
Yeah, Carolyn Dean.
Carolyn Dean. And so, like, anybody wants my Remag, let me know. Nah, I'll slowly use it. But you can take these capsules. I used to have magnesium chloride. The only problem with magnesium chloride is it does in the bottle what it does in your bowel, and that is the reason why it helps you with constipation is it strongly absorbs water. So it brings water to your hard stool that's giving you constipation. It helps. It's like a micro enema, if you will. So if you get magnesium chloride, I don't know if these are tablets or the capsule. Hopefully they're capsules. You got to keep it in a sealed bottle, otherwise it's going to go. It's going to get wet and yucky and unusable very quickly. So anyway, we picked on Paula, but not on Carolyn, not because I wanted to pick on her, but I want you to understand, a little bit about everything has a little different electrical force. Okay, and there are other factors that affect that. If you can't get it into solution, if it's not soluble, it won't work. So here's the magnesium chloride. You kind of see the size relationship. This is more congruent, and here we go. And why would it go there than here? So here's my analogy. How many full-size humans mate with a pygmy? Let me know, Dr. Stark, if that tickled your funny bone or not. Paula Dean is a TV personality. Thank you very much. I don't know that answer about the malate. I have to look at studies, and I'm going to explain why some of these counterions might still be of physiological concentration that might work. But anyway, yeah. So this is a disproportionate, and when they're disproportionate in chemistry, they don't bond strongly. So this is going to be the stronger of the two. And so if there's a ton of the chloride around, the magnesium will prefer this guy, same size compared to this disproportionate size ratio here. But the reason why I can rationalize that it won't be all gone, okay, I just stole this from a video, is even water can dissociate. So water is extremely, I'll comment on the magnesium oxide in a minute, probably it brings a good point. But even though water is extremely stable molecule, in a glass of water, there's still protons, so hydrogen, cations, and hydroxide. So you're literally drinking a little Drano every time you have water, but it's infinitesimal. So the water in solution is 99.99999% H2O, but there's a little teeny bit of protons, acid, if you will, and hydroxide, lye, Drano, or caustic, whatever you want to call it. So what that means is if water so strongly held together can dissociate, then the magnesium chloride won't be, the magnesium will then gravitate to some of the glycinates. So there will be some magnesium glycinate still floating around. So if that counterion has benefits in terms of pharmacokinetics, moving through your body or going through membranes or across the blood-brain barrier, then it still makes sense. But most of it's going to be in the chloride form. And so if you're going to take magnesium, just to have magnesium for, calming, for vessel dilation, for, improving bowel movements, constipated, cheap magnesium chloride is the way to go. So that is that. We won't go into that. But let's see. Do I have So, and I just want to go over this curve again because I've had it, a little bit. But what I didn't talk about is all these reactions still have an activation barrier. So enzymes bring the activation barrier down, but then I just added this little thing with this arrow, heat. So these are the reactants, and if, let's just say their energy is here, they have to get pushed to go up over here. So the enzyme, without the enzyme, they have to go up this huge hump, and our internal temperature without enzyme would be, high. We wouldn't be alive the way we are today. It'd be an enormously high temperature in our internal bodies, and we'd be very sluggish because we wouldn't be going very fast. But the enzyme brings that activation barrier down, and most products are release heat. But we eat calories, so sometimes where we end up is actually at an energy level that we had to put energy into the system to get them to they're less energetic than the reactants. But temperature will push the energy of the reactants up. Enzymes will push the energy of the reaction down, and that's why then things go even much faster. That's why I'm suggesting what the other cultures do: no ice water before dinner, no ice water after dinner, hot tea, soup, something like that with your meal. No raw foods, cooked foods, temperatures higher, already broken down. All that will help digestion much more. Okay, so let's see how much time I killed. We'll try to segue into, the last one here. So how PEMF works. I think PEMF is brilliant. And getting the right system with the right energy is critical, because if you shine one candle worth of light on you, it's meaningless. We need to get to the 200 Gauss to 2000 Gauss or higher.
Absolutely.
Beamer, 1 Gauss.
Mm-hmm.
My system, 3 Gauss.
But that's the nice thing about the the micropulse and the flex pulse. They all start at 200 Gauss, and they're very reasonable costs in the $600 to $1,200 range.
Yeah, absolutely. But what was brilliant, and when he talked about the Faraday experiment, I looked it up, and Faraday's law of induction. So why is this important? Because light interacts with molecules and macromolecules very easily. So if it does, that means it doesn't penetrate deeply. It gets absorbed by that, and it ends. But magnetic energy, there aren't a lot of magnetic compounds in the period. We have iron, and that's a ferromagnetic substance that may interact with the magnetic field. But for the most part, a magnetic field will just penetrate the body like it will penetrate air. And so it's just the further you are from the source, the less magnetic field you have, but you don't have these perturbations in your body blocking it. And then the magnetic field produces an electrical current, electrons for energy, electrons for healing. It's excellent. So the PEMF, in theory, to the best of my knowledge of these substances, these concepts, will penetrate more deeply than light and still produce electricity. You may not have the same flux or the same amount of electrons produced, so you just spend more time at it or get a higher Gauss machine or whatever. But at the end of the day, you're producing electrons, and you're producing electrons deeply. We'll talk next time about how infrared can reflect, and even if it's going straight and there might be something in the way, but there can be reflection as well. So the near infrared can actually penetrate fairly deeply as well. But I think the magnetic field will go deeply. So electrons heal. But then, I pose this question because we still have electron stealers out there. Do electrons kill infection? And, we talked about at the very beginning that it's reactive oxygen species, the anti-electron that kills pathogens. So what I think about PEMF and some of these other energy modalities is they're really not anti-infectives in any way. You have to have oxidation for that, for the most part. So this is a healing modality. So if infection or electron stealers got you into that state where you need healing, and they're still present, then you're shoveling against the tide a little bit. So these two concepts of energy medicine and killing infection through some other means, hyperbaric oxygen, ozone therapy, whatever works, whatever's appropriate, boosting immunity, they have to go together. Okay, and hopefully that kind of ties things together in terms of like, what will this technology really do? It's a healing technology. It's healing, not supporting or augmenting so much your immunity. So light therapy appears to be working through newly recognized, this is 2008, but how does light work? Light hits on something, promotes an electron to a sort of free state, an excited state or a free state, and they relax quickly. But if there's a need for those electrons, they can be grabbed. So mitochondria, cytochrome C oxidase grabs the electron, gives it to melatonin, gives it to glutathione, and then they're there to make sure that the electrons go down the chain to produce the carbon dioxide and water in your cells. We're breathing out carbon dioxide to optimize the energy output of that system. So it's a really important thing. Maybe PEMF does the same thing. I'm pretty sure it does, but it's not that in nature, magnetic fields are substantially lower compared to the energy delivered to us by light. So really, PEMF is really a strategy to amplify the effect of the magnetic fields that we are, because what Dr. Pollack said is that we're at 0.7 Gauss just here on Earth from the natural magnetic fields, and we need 200 Gauss. You can see how much we have to go to really affect healing. So PEMF is really a way to augment that magnetic field, whereas the natural sunlight already has the energy and the chromophores that we evolved to have to interact with light to affect this antioxidant oxidation, energy, and healing process already. But I think PEMF is a brilliant adjuvant therapy. But I think everybody should be doing light therapy, getting out in sunshine, trying to stimulate the sunlight, all that good stuff. And if you have any aches and pains or whatever, doing the PEMF as well. So they work together, and at the end of the day, they're both producing electrons. But the light that just naturally comes is ready, set, go. Whereas the magnetic fields aren't, and we have to do some tweaking to make it work by a factor of 300, roughly. So it's a big difference. It's natural magnetic fields are pretty weak. So, and we talked about this last time, and I'll just cover a couple points. So I bring this Tuesday group to the same point we were on Monday. The reason Americans are much less healthy compared to people from other developed nations is we're not using enough PEMF. But see, that's a device, that's a cost, but sunlight is not. So we don't spend that much time outside. The average American spends 93% of their life indoors, with 87% being inside buildings and 6% inside a vehicle, where you have the glass that filters out at least a portion of that light. And during the meager 7%, the sun will mostly covered head to toe or slathered with sunscreen. And I told the story about my godson who, African-American in Massachusetts, and his mother, this violin virtuoso, slathers the kid with sunscreen all summer. It's mind-boggling. So this is from the Health Reformer. I went to Crans, Montana to Switzerland to present on Alzheimer's. We were basically meeting, 24 of us, with just a big below an old brick structure, which was a sanatorium for leprosy and other disorders.
I want to start hour two. So I was looking in the Getter chat. Proud Patriot. I want to give a big shout out, happy birthday to Michael. It's his 9th birthday.
Go out into the light and warmth of the glorious sun, Americans, and share with vegetation its life-giving, healing, health-healing power. So this is the thing that Roger Schwelt talked about from this paper by Zimmerman about 6 years ago, that only recently has information emerged that infrared radiation from the sun directly...
Who else is in here? I see a lot. I see a lot of people...
to produce melatonin. 95% of our melatonin is in mitochondria, not in circulation to calm us down when the sunshine goes down by action of the lack of sun on the pineal gland. It does so intracellularly, specifically within the mitochondria, where oxidative stress from producing cellular energy is occurring. So, producing energy
extended it
is
like 3 months, right?
And if you have infection, that's oxidative.
I don't know.
So somehow,
what are all these numbers that are going?
Sync. We have to do something reductive or antioxidative, and sunlight does that. It's not the only thing, but it's can be a key thing. This is similar to the brain and cholesterol. Cholesterol is so important to tissue that's working very hard and breaking down, like the brain, that the brain produces its own cholesterol. Just so when the foolish pharmaceutical industry tries to shut it down, it has somewhat of recourse. Sometimes it fails. In the case of these new biologics, as Dr. Carter is well apprised of. But the body also has this mechanism from sunlight to keep that electron transport chain, your energy chain, working well by rejuvenating the antioxidants. And so that's a very specific thing. Like glutathione is not going to interfere with your antibodies' oxidative power or your white blood cell neutrophil oxidative power, because it's working inside the cell, specifically tuned to specific components of the electron transport chain. So, how sunlight and infrared improve health? Our bodies obtain the melatonin it needs in 3 ways. So I didn't really talk about this last time, but at nighttime in dark environments, the pineal gland starts the production of melatonin. However, it's now believed that this process only accounts for about 5% of the melatonin needed and used by our body. The melatonin produced in the brain has 2 purposes. First is to send a go-to-sleep signal. Lack of light in the eyes also signals cortisol production to stop. The combination of low cortisol and high melatonin triggers sleep. Importantly, because we mainly sleep to repair our brains and eyes, the melatonin produced in the pineal gland plays an important role in brain and cellular detoxification, antioxidation, or anti-inflammation. Exercise is an inflammatory process, and we take anti-inflammatories and, diet, and we rest for that repair, and then the tissue comes back at least as strong or strong before. Your brain and eyes are your athletes in your body. So that's creating a lot of oxidative stress. And so it's really important to get the sleep, and this is what it's all about, is that melatonin is there as a antioxidant agent for that tissue. The pineal gland, let's see, I think the pineal gland was fat. It's just third eye for many reasons. What do we say? Supplementation. Supplemental melatonin goes into circulation, provides it to the body. Generally, if taken during the daytime, it may signal a sleep response, which is in conflict with what the pineal gland is doing because it is still being exposed to light and producing cortisol, not melatonin. The light induces cortisol secretion through the suprachiasmatic nucleus that activates the adrenal system. So adrenal fatigue, lack of sleep, making sure that we're melatonin sufficient. And, because it's an antioxidant, we want to reduce our overall oxidative state so that we have a sufficiency in melatonin to allow us to sleep well, as an example. That's why, I always say, when you're not sleeping well, you have an inflamed brain. But now I realize it's not just you have an inflamed brain, but you're not giving yourself an opportunity to produce enough anti-inflammation, melatonin. In the daytime, by the action of infrared light on mitochondria, melatonin is produced intracellularly, that is inside cells. The process explained below, and we'll go into that next time. But 95% of the melatonin in our bodies produced this way. It is produced in the daytime to manage oxidative stress from our activities, from sunlight, obviously, daytime. The melatonin produced at nighttime is insufficient to meet the needs of daytime antioxidation. Thus, the critical second mechanism for its production is crucial. Therefore, sunlight exposure is vital. Thank you, Grammarly, for making sure I used different words there. Because I had crucial and crucial people. Without adequate intracellular oxidation, damage repair, chronic diseases erupt. That's why sunlight helped so many people with chronic conditions. And with that, we made it.
What have you come across for melatonin and mitophagy? This is kind of similar idea as autophagy, right? We're removing inefficient cells or senescent cells, but where melatonin is doing that for the mitochondria.
Well, everything wears out eventually, Andrew. So, for example, why you poop brown, right? Have we ever had that discussion?
I have, yeah.
Can you send me a snapshot? You poop brown because God's telling you that whether you're 2 or 102, you poop brown, you're always rebuilding tissue and pretty much at the same rate. So red blood cells, when they're de-ironed by the kidney, turn brown, and the preponderance of the reason why your poop is brown is because you have old, worn-out red blood cells that are now brown blood cells because they're lacking iron. So this antioxidant cycle, there's still a life cycle for pretty much every tissue in the body, even bone turns over. So there's sort of complementary mechanisms, I think, is how I'd answer that. Is that adequate, or was your question deeper than that and I missed more?
No, I think that was plenty fair, yeah. And I think Dr. Carter, you even said that you take, was it like 15 milligrams per night? Like you take it every night. And there's a question.
Yeah, I use the liposomal melatonin from Quicksilver. And, but, there are studies, going all the way up to 200 milligrams, mostly the transdermal or, suppository, but very strong anti-cancer capabilities. With COVID, that was one of the things that I also use in my protocol because it also enhances natural killer cell function. So it has lots of benefits.
It does, yeah.
Julie, regarding your question about sunlight in northern climates, you got to get the halogen lights. And then watch a couple of Jack Cruz videos and go to Mexico every once in a while and try to compensate. Get some sunlight, but the halogen lights are the cheapest way to get simulate sun exposure. So that's how I do it. Are you recording this? Yes. Rafaela, I'm not ignoring you. I just haven't had time, but I'll do my best. Walter, is dimagnesium malate better than magnesium 3 and 8? So there's good studies on magnesium 3 and 8 crossing the blood-brain barrier. So I think there's a little. If you take magnesium 3 and 8, there's going to be a little magnesium 3 and 8. Not all magnesium 3 and 8 for sure, but you're going to have mostly magnesium chloride. And just enough of that may get across the blood-brain barrier, more so than the magnesium chloride. But
it's not enough elemental magnesium, though. So even though it says like 2,000 milligrams, is a very small amount of magnesium in there. So I like to have my patients do a minimum of 400 milligrams of magnesium a day on up to 800 to 1,200, depending on, what's being addressed. So I like I use the ionic magnesium, which is similar to the Remag, but a lot less expensive,
Yep.
from trace minerals research.
And my rationale is it's just as good then because of what's going on. But
Right.
to answer the question about magnesium oxide, I take a triple mag. And the reason why I do that, triple mag means it's magnesium with 3 different counter anions, the negatively charged part. And why I do that, if you have good absorption, good gut, you can get away with magnesium oxide. Magnesium oxide of all the counter ions is the most stable. So it's least likely to dissociate. And if it doesn't dissociate, it doesn't dissolve. And if it doesn't dissolve, it doesn't absorb.
Right. Exactly.
Okay, but if you have a good gut, when you take a triple mag like I do, you literally are taking something with time release, because the magnesium citrate in my triple dissociates immediately. Boom. The magnesium gluconate or whatever else is in there probably a little slower, and the magnesium oxide the slowest. So you get sort of a time release effect. But like if you go to CVS and buy magnesium, it's going to be magnesium oxide almost 100%. And most people who are buying that have poor guts. So they're likely getting very little absorption of magnesium from the magnesium oxide supplement. So is magnesium oil the same as magnesium chloride? Most likely, read the label, because it ain't magnesium. It's not magnesium metal, elemental magnesium. So there is a counter ion, and just for the vernacular, the magnesium as an ion is called a cation, positive, and then the counter ion that balances out the charge because everything has to be neutral is called the anion. So the magnesium oil definitely has some counter anion associated with it. And what they're doing is they just have something very soluble, a very soluble magnesium compound that can be super concentrated in water and make what effectively looks like an oil. That's my guess.
Yeah, it's usually magnesium chloride, though.
Yeah. And ionic foot baths have somewhat of the same effect. I think some of these things absorb. We have a stratum corneum, which keeps things from just penetrating our skin, and certain things will and will not. But I worked with this Harvard guy a long time that created a very unsexy term for skin penetration called a hostile biophysical environment. I said that's a big sales campaign. I want a hostile biophysical environment on my skin too. Where can I get this? but literally, the end of the day is all he was doing was creating a very high salt concentration, and that salt concentration was tying up some of the charged particles that resist the penetration of the stratum corneum, and so other things could sneak through. So if you put high salts on your skin, my guess, without doing research on it, is that it will likely penetrate. And Epsom salts have been known for years to do that. Does oral melatonin from the supplements get to the intracellular mitochondrial level? Maybe.
No, I don't think so. I think really it's only from the sunlight, from what I'm understanding.
Well, Jack, I don't agree. You said consider researching Carolyn Dean's pico-sized magnesium. There's only one size, the basic magnesium ion. There ain't nothing smaller or ain't nothing larger. Okay, so when you have something that dissolves, she says ionic, that's the key word. Ionic means it's magnesium 2+, and that's just the way it is. There's nothing else. You're going to have a counter anion. Anything that's absorbable has dissolved into the magnesium 2+ and the 1 or 2, whatever the charge is, counter anions, and they're swimming around together, but they're not bonded. That means they're dissolved, and they're all just magnesium 2+. There's no, you can use fancy language, but at the end of the day, it's just basic chemistry. Does melatonin as a supplement reduce the amount the body makes?
No, they've done a lot of studies on that. And the issue is, as we get older, we are losing our capacity to make melatonin from the pineal gland. And of course, as we get older, there's calcification of the pineal gland, which also reduces the secretion of melatonin. So I think it's very beneficial for people to take at least, some people can't tolerate the higher doses, but in general, that's because, you're not detoxing effectively and binding. So those people who actually have side effects from, let's say, taking melatonin at night and being, having weird dreams or being groggy the next morning, it's better to take a binder with that, because of course, when you're sleeping, your brain is detoxing and it's shrinking and so forth. So that's another indication that that you're toxic and so forth. So that's where the binders can come in.
What happens on cloudy days? Two things. Number one, you have more moisture, more water. Whatever frequencies water absorbs will be less likely to hit the earth. And then you get some refraction. So you're going to get less intensity, possibly across the entire spectrum, but not necessarily. So, there's a myth about, cloudy days. You probably get a fair amount of UV still, and some visible, because it's obviously still light out. But then wherever water absorbs in the infrared and near infrared, those bands, we get a wide spectrum, and water's not going to absorb across the entire spectrum. So some will penetrate through unimpeded, and others won't. So you can go on. Did I say Google? Yeah, I did. Google Images. I actually was talking today with Dr. Michelle and saying that Google isn't all bad, but mainly is. But anyway, so you can go look at what the spectrum of absorption of water is, and those are wherever there's a big peak, that's the light that's not hitting the earth. So you're definitely not as much. You're definitely not getting as much light. But let's see. I had a good experience with Calm, which claims to be ionic. They're all ionic. It's just all a question of what the counter ion is. And the dose makes the poison the cure. So some magnesium supplements, it might just be as simple as you're getting more magnesium, 400 milligrams versus 300 milligrams in something. That can make a difference. Excellent. So Dr. Stark's enjoying her sound therapy in her ears. I take magnesium with taurine for a practitioner. So once again, you may get some added benefit from the taurine counter ion. In fact, taurine, certain forms of taurine, called derivatized taurine, are anti-infective. So that's well published. So in some cases, it may not be the effect of the magnesium taurine substance, but the magnesium then finds its chloride, and taurine can go off and do other things. So that's a possibility. And with that, hey,
Dr. Carter, I might throw in one more. Do you ever go a few days without melatonin? Do you find that you sleep as well or get to sleep as easily?
Yeah, I do. Yeah.
Interesting. That's the only thing I find, even with the liposomal, that I don't seem to get to sleep as easily if I stay on melatonin for a while and then cycle off. That's the only reason that made me kind of doubt it. It's interesting, but
yeah. And Dr. Stark pointed out that Calm is magnesium citrate, so that's just magnesium citrate. You go get the concentrated liquid if you want to clean yourself out before a colonoscopy or something like that. So, and of course, in that form, if it's already dissolved, it's already bioavailable, but it's already ionic magnesium, no matter how you slice it. But you got a bunch of citrate there. But when it hits your gut, there's going to be some chloride there as well. But with that, I hope everybody's a little more astute on chemistry and electrochemistry today, and really appreciate
and stoichiometry.
Stoichiometry, you said it, Andrew. I can always count on you for paying attention
Recycling electrons.
to some of the weird details.
Hey, shots fired.